today I'm going to be talking about using inscribed angles. This is chapter 10, section 4. So first off, we have to talk about what an inscribed angle and an intercepted arc is. So it says, if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. All right? So let's talk about what an inscribed angle is. So if we were to draw a circle, okay, it's an angle whose vertex is on a circle, and both sides of the angle go all the way to the circle. So what this looks like is the vertex is going to be on the circumference and go all the way to the other side of the circle. That is an inscribed angle. An intercepted arc is the arc that corresponds with the inscribed angle. So the intercepted arc is that arc that corresponds with that inscribed angle. Remember, at the last lesson, we had a central angle. And a central angle, the vertex was on the center. Now we have an inscribed angle. And an inscribed angle, the vertex lies on the circle. And the top sentence means that if we have an arc measure of, let's say, 30, the angle measure is going to be 15 degrees. And we can do vice versa. If the angle measure is 15, then the arc is 30 degrees. So the arc is twice as big as that angle. So we're going to use that concept to solve. So let's look at this first one. What is the measure of angle B? So we're looking for angle B right here. We're looking for that angle. And I know that the arc from here to here is 60. If I have an arc of 60, if I'm finding that angle, I divide by 2 and I get 30 degrees. So the measure of angle B is 30 degrees. So if we go from arc to angle, we divide. Now what if it's the other way around? We're finding the arc MNO. We're looking for MNO. And I give you the angle measure right here. I give you 115. Now if I give you the angle measure and if we're looking for the arc, we multiply by 2, and that's going to be 230 degrees. Let's do that in red. If we go the angle to the arc, we multiply by 2, and that's 230 degrees. The arc is twice as large, the angle is half. Okay, let's do some more. This time I just give you different pieces. So this is where it starts getting into the puzzle work for these circles, okay? So I'm asking you for the measure of angle D. So I am looking for this angle right here. We need to find that, okay? But we need to find its arc to find the angle. But we don't have this arc. We don't have this. All we have is we have this arc right here, which is 50, and this arc right here, which is 80. Okay. So if you notice, I have this green piece, which is 50 and 80, and we're looking for the red piece. So what we can do to find the red piece is we can add 50 plus 80. We can add those two pieces together, and we get 130 degrees. So the green piece, let's do that in green so it matches. So 50 plus 80 is 130. So that entire green piece is 130 degrees. Well, if that green piece is 130, to find the red, all we have to do is take 360, subtract from 130, and we get the red piece. which is 230 degrees. Now, we know this red arc is 230 degrees, but do not stop there. We were looking for the measure of angle D, the blue. If we have an arc measure, we divide by 2 to get its angle, and that's going to be 115 degrees. Always go back and check what you're looking for, because there's a lot of pieces that you have to find before you get your final answer. All right, let's do another one. It says, what is the measure of arc MP? So we're looking for this piece right here. We do not know what MP is, all right? And it doesn't look like we have any angle associated with it, so I'm going to look at the things that I give you. All right. First off, I tell you that this arc right here is 120 degrees. There's really nothing we can do with that, so we go on to our next piece of information. I see that I have an angle, an inscribed angle that's 55 degrees. If I have an inscribed angle, I can multiply by 2 to get its arc. So I can multiply by 2 and get its arc, which is 110. All right, so sometimes you kind of have to look at what you have and use what you have. If you have an angle, an inscribed angle, you multiply by 2 and you get that arc. Now what I notice is that I have 110 degrees, I have 120 degrees, and I'm going to add those up. 110 plus 120. And I get 230. So this whole piece of this circle is 230. Well, I notice that the blue piece that I'm looking for is 360 minus 230. So to find the blue piece, I do 360, the whole circle, minus that black piece to get my remaining blue, and I get 130 degrees for this blue piece. And was that what we were looking for? Yes. The measure of arc MP is 130 degrees. So like I said, these have lots of puzzle pieces to them. So you have to be very careful of what you're looking for and what is given to you, and just start filling things out. Let's try another one. Okay, so for this left one, it says, what is the measure of angle BAC? Let's look at this, angle BAC. We're looking for this angle right here. We don't know what that one is, okay? So let's see what I give you. I give you this arc right here, which is 70 degrees, okay? But that doesn't really help me. I need to find this arc to be able to get that angle. So we have to figure out how to find that red arc. What I notice is that I have a diameter, and a diameter gives me a semicircle, or 180 degrees. So to find that red piece, I can take 180 minus 70, and I can get that red piece, that red arc, which is 110 degrees. Now that I know the arc measure, I can divide by 2 to get that angle, and that is 55 degrees. So the measure of angle BAC, let's put that down here, the measure of angle BAC is going to be 55 degrees. Okay, so that one's, you got to be able to check for those diameters. The diameters give you that 180 degree, that semicircle. Let's do another one. We're finding the measure of arc AC. All right, what they give us is they give us an angle. They give us 15 degrees for this angle. If I have 15 degrees as an angle, I can multiply by 2 to get that arc, which is 30 degrees. That's 30 degrees. And what I notice, I have another diameter. So I know from here to here is 180. So to find the blue piece, all I have to do is take 180 minus that 30, and I get 150. So that blue arc is 150 degrees, and that's what I was looking for. The measure of arc AC is going to be 150 degrees. So you just have to be really careful, especially looking for diameters, because that's going to help you the most. Those take a little bit of practice. All right, we're moving on to something a little bit different, okay? We still have inscribed angles. If you notice, I have a red inscribed angle, a blue inscribed angle, and a black inscribed angle. And it asks you, what can you conclude about angles M, N, and O? Well, what I'm going to do is I'm going to look at their arcs. So I'm going to take the red one first. If you notice that the red arc goes from here to here. Let's look at the blue one. The blue arc goes from here to here. And the black arc goes from here to here. So if you notice, all the arcs are exactly the same. They're exactly the same. So let's just say that this arc is 20 degrees. To get its angle, we divide by 2, and we get 10 degrees. So if the red arc is 20, the red angle is 10. If the blue arc is 20, the blue angle is 10. And if the black arc is 20, then the black arc is 10. So if we have inscribed angles that have the same arc, then those angles have the same measurements. So that means angle M, N, and O are equal. That one's a little tricky to see, kind of does a little trick on your eye, but you have to look at where they all end, where their arcs are made. If they have the same arcs, they have the same angles. So all those angles are equal. So let's use that piece. Okay, so if we look at this, it says, if you know that the measure of angle O is 75 degrees, all right, angle O is 75 degrees, what is the measure of angle N? Well, if you notice, the red angle has an arc from here to here, and the blue angle has an arc from here to here. So since they have the same arcs, they have the same measurements, so the blue angle must be 75 degrees. So the measure of angle N is equal to 75 degrees. So you just have to be very careful to see if they have the same arcs or not. Now our very last one, it is about a quadrilateral that is inscribed in a circle. Notice all the vertices of the quadrilateral are on the circle. They lay on that circumference, on that circle. That's what inscribed means. If this is the case, the rule is that the opposite angles are supplementary. Supplementary, again, means 180 degrees. So opposite means across from each other. So my two opposite angles are X and 68. So those two angles are supplementary. Well, supplementary means that they add up to 180. So I can say X plus 68 is equal to 180. 180. So now I can just solve for X. So I'm going to subtract by 68. And I get 112. All right. To find Y, what's opposite of Y? It's 82, and they're supplementary. They're supplementary. So Y plus 82 equals 180. So we subtract, and we get 180 minus 82 equals 98. Now this is only the case for quadrilaterals that are inscribed in a circle. They're not equal like we learned before in parallelograms. Don't think of it like that. These are not parallelograms. These are just quadrilaterals inscribed a circle, and their opposite angles are supplementary.